Warning, ultracapacitors can be very dangerous. They can cause harm to yourself, to others, or your property. Make sure you follow all the safety standards before you start building and working with supercapacitors or ultracapacitors. Hi, welcome back to the Gapster channel. My name is Gabby, and today we're going to talk about building this 15 volt power supply using supercapacitors. These are 600 farads, 3 volts. So there's 6 of them. So this could deal with up to 18 volts, but we're going to basically charge it to 15.2 volts. And you can also do 2 of those and do a plus 15 and minus 15 as well if you choose to. So what you need for this, so this is based on the supercapacitor, there's a balancer, and there's the UCPure board that's going to control the charging by Ian Canada. It's called the UCPure. This is the Mark III that has the capability of charging between songs as well. We will also have a DIY build by one of my subscribers that I'll feature towards the end of the video, so make sure you check it out. Also, if you have a system that you are building yourself and you'd like to share it with us, just send me an email with a few pictures and a description and we'll go from there. We are also going to talk about some safety layers, also how to keep an eye on your ultracapacitors from time to time, because I've had one that actually was bulging and without doing anything to it. So you never know, always check things, and we're going to talk about some layers, also safety layers on how to check things with your balancers and stuff like that. So this is a series of trying to show you guys. I've done like the 3.3 volt, the 5 volt, plus 5, minus 5, and now we're doing the 15 volts. So I'm trying to cover the range of all these different supercapacitors, and this way if anybody is building those, they'll have some idea. Please don't follow my ideas completely. I'm not sure if my systems are fully safe. I'm trying my best. I'm trying to show you guys some layers of safety, but you have to do your own diligence and make sure that what you're doing follows all the safety standards. Very quick thing for people asking, what's this, what's that, what are these? Balancing board is you have capacitor that can only handle 3 volts. And you're charging for 15. So we want to make sure that each capacitor doesn't get charged more than 3 volts. So this balances the voltage between all 6 of them. So that's what we call a balancing board. This is a charge controller, the UCPure Mark III, and this is going to be charging. So you're going to put here either DC or AC, about 18 volts or so, and you're going to charge the capacitor with this. This is going to be charging them, and once they're fully charged, it's going to disengage completely, and then your load is running purely on the ultracapacitor. And this is the beauty of the system, is if you have a load that doesn't use much power, say a couple op amps, this could run them for hours on their own. So this is the purest power you can get when there's nothing connected to them. All right, so what you're going to need is you're going to need a balancing board. You can have a balancing board like this. This takes 6 ultracapacitors. We'll get to those in a second. So 3 and 3, or some of them come in a little strip that's long as well. Depend on the space that you're trying to use. It might work better for you to have them all in the long way, or maybe more as a square. I'm picking a square here for my purposes. And you're also going to need 6 ultracapacitors, or what you call supercapacitors. These are Cornell Dubilier from Mauser's, with a reputable company, and these are 3 volts, 600 farads. I strongly suggest you buy a brand name ultracapacitor, because for safety reasons, I think you'll be better off. It's something you really don't want to mess around with. As far as the balancing board, this is rated for 3 volt cells, so some of them are rated for 2.7 cells, so make sure to use the appropriate one. And the last thing you're going to need is the UCPure from Ian Canada. This is a UCPure Mark II, but I suggest the Mark III. I've got a couple coming still, but they're pretty much identical. The Mark III can charge between songs, and that's what's really cool about it. So while it's discharging, every time a song finishes and the other one is starting, that one quick second they will charge, and that just can keep them going. That's enough to keep them going for pretty much the whole time, and also keeps the voltage at a much more steadier pace. So I strongly suggest the Mark III. Okay, now the big question: how do you configure the UCPure to be 15 volt? So the UCPure can work on 3.3, 5, or 15 volt. It depends on the jumpers. And what people find confusing is people look at the board and there are no jumpers. What Ian refers to as jumpers are these little tiny areas here. This one is called S6, this is S2, and this is S4. They all have little resistors on them, except the S4 actually has a 0 resistor, which is basically, it's like a short. So for 15 volt, if you look at this little area here, it says for 15 volt you need S2 needs to be open, S4 needs to be open, and S6 needs to be open. So we need to remove all these three resistors, and that's what I did right here. You could see that S2 has nothing, S4 has nothing, and S6 has nothing. And how do you remove the resistor? You just pretty much put your soldering iron just on an angle, kind of like this. I'm just going to simulate, because I'm not removing those, simulate, let's say this is the iron. Just put it like this and tap between front and back a little bit, and by the time they warm up, you just flick it out. And same thing with the other one. And you're going to end up with tiny little pads. And when they say, for example, if you're designing a 3.3 volt and it says too short, means you can do that and then you put a dab of solder to join them together. But in this case, for 15 volt, we're going to remove all three of them. So like just like this one, that's removed, S2 removed, and S4 removed. So 6, 2, and 4, the resistor has been removed. And that's what we call the jumpers. So to get going, you're going to take those capacitors. They do have four terminals here, but only two of them are actually effectively working. There's a ground negative and positive on the opposite side. The other two are just for stability. They have no purpose electrically whatsoever, just to make sure they're basically solid to the base. So what you want to do is make sure the negative goes on the negative, and so you go like this, same thing. Negative in this case goes here, and go like that, flips them upside down, and then you're going to solder them. So we're going to solder all 6 of them. All right, so here we go. Next, we're going to mount the UCPure on top of this if you want, but I found this is already too high, and I'd rather mount it to the side. So what I did is I put a couple plastic standoffs here, you can see them, and I drilled a little hole in one. I've got to drill the other hole still, but I'm going to wait to line it up properly. And so I did a small hole here as well, though I did it before I put the capacitor. I didn't want to be too close to it. On the other side, I got a bit more room. And this one, then it's going to mount right in here. Now I'm just seeing that my standoff is a little too long, just like this, that I've got enough room to put it in. The plastic standoffs are easy to source and they're really cheap. I'll put a link for them. You get them in a box. I'm actually almost out of them. And you got a whole different sizes of them. And I gotta get me another one of those. I'm pretty much all finished. So I put a screw on one side here. We're gonna put a nut on the other side. And I'm just gonna tighten that. There you go. Doesn't have to be super tight, it's good enough. Now the other side. Make sure I don't mess it up. So now that I know, so I have this touching exactly. I know it's going to be here. There we go. Perfect. There we go. So now what we're going to do, again, put another little screw. You can buy those. I'll put a link. So if you're doing 6 like here, so you'll need 6 of those instead. So that's 2, 4. You can, so then you have a massive block. And that's okay if you have an application that takes a lot of juice and you need lots of power, then yes, 6 of those could be a good idea. But in my case, I'm using a TDA 15418, hardly takes anything, so I really don't need to use a big giant one. Okay, so we got the 4 standoffs here that's going to sit on. And sometimes I like, instead of putting through, I like putting one, like another standoff on top, just in case in the future I want to mount a wire or secure a wire, or maybe put something. You got options. So here you have it. So next thing is we're going to wire it. I'm just going to zoom in closer on this so you guys could see even more. Okay, so here it is. I just want to show you how I secured the UCPure to the side. Just a little standoffs here and a screw through it. So I get a piece of wire here. There we go. It's kind of nice and smooth. So what I did, I just flattened the wire a little bit. We got a little better contact. So this is a lot much better. So now we're going to rely on the fuse here that's on the UCPure to basically save us from disasters. One last thing I want to do is to secure this board so it doesn't have too much flex. So we're going to slide a couple of weather stripping pieces. You can get those Home Depot or whatever hardware store you have. So I've got 2 small tiny little zip ties because it's a very small hole. The big ones don't fit in. So I'm just going to slide this one in here. And tight. There you go. So here you could see that it is mounted in the box, and here's the lid. It's another safety feature. So now it's inside, it's not going to be tampered with, it's not going to move. So that is another layer of safety. It's still not safe, it's never safe, it's just another layer of safety. I just finished mounting the actual 3.3 volt as well that we've designed earlier, just to show you that they can fit in the same box. You could see there's a screw that goes in here and a screw that goes in here, and that locks this thing in place. This one is locked with the 4 standoffs as we showed before, and so this is solid. They don't go anywhere. And what's nice about it, you can put a nice lid on top of it and screw it in. You could leave a tiny space between them, just lift it up just a little bit, and you can run a couple wires here and there, and that also acts as ventilation. The other option would be to mount 2 of those banks, so then you have plus 15 and minus 15. So the next part in this video talks about how to charge this bank of supercapacitors, and how long does it take to charge and discharge, and timing. And this you can calculate for your project, is this is good enough size capacitors for you. If not, you might want to decide to use the big ones. So I go in details and measure everything and time everything. Also, it helps other people that don't know much about the UCPure, how it actually works, what is pure mode, and so forth. If you decide to skip this part, don't remember that at the end there is a part about subscriber build of this video, so make sure you check it out. So I've got here a laptop charger, and we're just gonna, that's one way. This is an 18.5 volts, which is ideal, so we just plug it in here. The other option is to use a transformer and use an AC voltage. And for that, you just have to get yourself a transformer. So if you are using a transformer, you gotta make sure you have, because when you convert it to DC, you will get a little bit more. But again, consult with the manual for the UCPure. Ian has some specifications about that. And all you have to do is grab your AC line. And on the Mark III, it's got a terminal here, so you can actually connect this to it. On the Mark II, you actually have to solder it on it. So this is the other one. I'm going to make a special video about transformers, how to connect it, how to wire it to 110, 220, what's secondary, primary, and all this stuff. I'll do a separate video about that because I see a lot of people still confused about how to connect this part. All right, we're going to give this thing a try and see, show you guys how it actually works, how it charges, how what we call reaches a pure stage. So I'm going to use the laptop charger for this purpose, and right now it's showing, the battery showing at 4.54 volts. So this is actually hooked up to the actual batteries. So the light bulb here, which is a 12 volt car bulb basically, and it's connected via in series with a little 8 ohm resistor. Because this is a 12 volt now, I don't want to burn it with 15 volt, just reduces the voltage on it so it will survive better. So we're going to plug it in, we're going to reach, we're going to see how this voltage is going to start rising as soon as I plug it in. So now we're going to turn it on. So you could see the bulb is barely dim, just 4.8, you might not even see it, it's just a tiny bit dim. And as our voltage is going to rise, you're going to see the light bulb start getting brighter and brighter. So this should reach close to 15 volts, maybe. And when it reaches that stage, it will switch into pure mode. So what does pure mode means? Pure mode means the ultracapacitor will disengage from the charger completely, and they are now supplying the load on their own without any intervention from the power supply. And you'll see a little tiny blue light here which goes blue, and there's a pure beside it, so basically you'll know it's running in a pure stage. Also you'll hear a little relay clicking as well. So we're at 6.37 volts. Now, these are starting from pretty much empty, so it's going to take probably a good 5 minutes for them to charge. The first time will take some time to charge, but once they charge, after that, it doesn't take much time. So we are around 9.5 volts now. So we got to 14 volts here. We're going to start the timer, and we're getting close to that 15 volts. And we're just going to see how long does it take from 14 till it reaches pure mode. And again, one more time, even when it's not on pure mode, you're still running, your equipment is still running, but it's not on ultracapacitors alone. But still, the ultracapacitor is playing a good role into stabilizing your power. So it's actually not that bad. So you're probably not going to notice much difference in sound quality. There'll be a very negligible difference, but still when it goes into pure mode, then you'll see that the quality will improve to the max basically. So we should start to almost see, pay attention here. It's going to be the blue light's going to shine light soon. It's going to go into pure mode. So it's probably going to charge till 15 and a bit. And always make sure, put your hand on the capacitor the first time, make sure nothing's getting hot. Just make sure everything is running good. Here you go, it just clicked in. So 15.2 volts is when it clicks in. So that means now the power supply has disengaged from the load, from the ultracapacitor, and this light bulb is running purely on its own. So it took about 1 minute and 20 seconds to charge from 14 to 15 volts. So this is roughly how much you can expect time for it to charge. So even at the worst condition, it just takes pretty much a minute to charge, and you can, on a small load, you'll be able to run this for a couple hours. I demonstrated those in another video running the OPA 861, and I was able to run it for an hour and a half basically. So now we're seeing a countdown, so the voltage is dropping. And it's going to keep dropping till I'm not sure where it will click in. Let's keep watching it. So we're getting close to the 14 volt mark. And at 12.6, it clicks off. So, and now we're going to start the timer. And we're going to see how long it takes. So basically it's running between 12.6 volt to 15.2 volts. This is the range that it functions on. So when it dips at 12.6, it starts charging, and it reaches 15.2, it stops. Now, like I said earlier, and this is not really that critical. If we factor that between songs, we're going to keep charging this thing for 1 second intervals. So we are not going to see this drop the way we're seeing here. And most likely we can maintain the 15 volt throughout the entire time and listen to music in pure mode. So again, the Mark III is a good upgrade for the UCPure. If you have Mark I and Mark II, for some critical components, say let's say the clock on the DAC, for example, that's in the FIFO Pi, I would highly recommend you make sure you get the version 3, because you want that voltage to stay as constant as possible. So as you can see, it's been 1 minute and 20 seconds. We're already at 14.7. So I'm guessing within a minute and a half-ish, we should reach 15 volt. Yeah, 1 minute and 37 seconds. We got to 15, but let's go to 15.2 all the way. So ready to stop here. It's going to go pure. Just went pure. So 147. Now what we really need to measure, we know the voltage. We're going to measure how much this thing is consuming, so we can then make a correlation between different loads. So that's what I like about this Klein voltmeter. I bought it just for the amp meter here, but I end up using it for everything. It actually measures capacitors and stuff like that. It's a really handy product. I end up using it all the time. So I'll put a link for it in the description if anybody's interested in this. But let's measure the amperage here of how much we are using. We want to measure it in DC. What you want to do is zero everything, and then we are going to put it just around here. So this is exactly half an amp. That's 500 milliamps. So that's 500 milliamps. So let's say if I measured the OPA 861, for example, uses as 22 milliamps. So you get a long, you can use this for quite a long time. So we're dropping here. We're going to see how long it takes to drop all the way down. I'm going to put this thing back in here again. We're at 14.3. So how long basically it takes at half an amp of load to discharge. To 14 volts took 2 minutes and 45 seconds. And which is, I find 14 volts probably a very useful range. I would say between 15.2 and 14 is a really good range. I'm not interested in dropping all the way to 12.6, to be honest with you. I find that a little bit too low. I wish we had the options to decide when we wanted to charge or not. But again, I think with the Mark III and charging between songs, probably don't have to worry too much about it. But let's see how long did it take till 13.5. How much time can we use this for at half an amp of load? We're getting close. I'm just going to write it down here, 13.5 volt. And let's see how much time we can use it for. Okay, we're getting close here. Here we go, 4 minutes and 22 seconds. So 422. So I'm going to stop it here and let's just think about all this for a second. There you go. All right, so here's the results. As you can see, I wrote them down a little bit clearer. So it took 1 minute and 47 seconds to charge from 12.6 volts to 15.2 volts. These are like the extreme limits. And this is where the UCPure clicks. So when it goes below 12.6, it clicks in to charge. And when it reaches 15.2, it reaches pure mode and then disengages from the charger. The load I was using is roughly half an amp, so 500 milliamps. And the draining part from 15.2 to 14 volt, which is a very useful zone, it drained in 2 minutes and 45 seconds. That's at 500 milliamps. And from 15.2 to 13.5 volt, which is still useful, drained in 4 minutes and 22 seconds. So you can take this information and figure out what your load is and how long this thing is going to last you. Now bear in mind, this does not take into account charging between songs if you're using the UCPure Mark III, which was most likely is going to maintain your voltage either steady or close to it. And so let's say, for example, you're using a Mark II or Mark I, you're not charging between songs. So what you can say from this is that, say you're using a 50 milliamp load, then you're basically going to have 10 times more time. So instead of 4 minutes, let's say here, you're going to have 40 minutes. So something like that. And or if you're using 25, you're going to have 80 minutes of usage. So it depends on how your load is. On my TDA 1541A, I believe the load is around 15 milliamps, which is very low. So I could probably use this for a few hours anyway. But take this the way it is. So I'm just giving you ideas and on what to expect from your device here and how you think if this is going to be good enough for you to work with your load. So there you have it. If you don't think this is enough for you, then again you can build the Big Daddy here, the 6 of those big ones, the 3000 farad ones. Of course you're going to have to deal with a much bigger package, a lot more money. Each one of those is close to $100 Canadian, so maybe say 80 US. If you're in Europe, shipping and all that, it might cost you. Anyway, you get the idea. So it could get fairly expensive to build one. So it depends on cost and size. For me, size is also a big one because after a while, you really don't want to build a monstrosity of a piece of equipment. So if your load is small, this could work really well. If your load is big, you're going to use 6 of those. You still need only one UCPure. It's just the same idea, and you're going to put those in series as well. If you are building any ultracapacitor project, it's very important to check that the balancing is actually happening and that you're actually getting a proper balancing. And what I usually do, I'll take my measuring voltmeter here and I start measuring between each capacitor. So you should measure each capacitor and see how much is flowing. So this one is 2.72. 2.72. So you got to measure them all and make sure they are close to equal to each other. Another layer of safety I would like you guys to check is I once had a UC conditioner just like this one here you see, and it's been running like with my streamer for like a good 6 months. And I looked at one of the capacitors and it was bulging out. You could see this is one I actually took out. You can see the difference between these ones and the other one, how they're flat, and this one is starting to bulge out. So the moral of the story is from time to time double check to see if your capacitors are bulging or anything. Put your hand on them, make sure they're not overheating, and from time to time again double check that the voltages are balanced These are things that you should need to do every few months on your system just to double check to make sure it's running well. And now it's time for my subscriber DIY build. And this is a build by Mark, who built this beautiful streamer. So Mark built a streamer that I showcased on my YouTube channel, the flagship streamer that you'll see here. And this is his rendition of that same streamer. So he built it with a beautiful acrylic casing all around. Mark says that he's been very impressed by the output quality of the components. He's still playing around with different clocks and enjoying the nuances of the different clocks. He used 3/4 inch acrylic plate as a platform for the streamer. The clear acrylic allow for visualization of the monitor pi. The thicker acrylic provides good weight for stabilizing the unit. He's running it with his Denafrips Venus 2 DAC and Ellicott 2 preamp and an amp using the 300B tubes for output. If you happen to be building a system and you feel like featuring it on my channel, just send me an email. It's in the main page in my bio, just by the little arrow beside the Gapster. If you're planning to do plus 15 and minus 15 volt, you basically just have to do 2 of those and follow my video where I did the plus 5 and minus 5. Towards the end, I show you how to do the connections to do the plus, 0 and minus. It's exactly the same thing, except this is 15 and the other one is 5 volt. I'll put also a link in the bottom on how to build that DDC streamer DAC with Ian Canada parts as well in the bottom corner. There'll be a speaker if you feel like subscribing and supporting the channel. Talking about supporting the channel, feel free to join my Patreon. There's nothing much there, just mostly support. And also you can also support me with some super bucks. All this will help me buy more parts and show you more things and more videos. I hope to see you again in another video, so take care and till the next one.